In this recording, we're going to look at transformations of quadratic functions. We're going to build on your knowledge of vertical and horizontal shifts and reflections that we studied in our previous unit. And so we'll kind of go through that part quickly because that's a review, but then we'll spend a little more time on the dilations, the stretches, the horizontal and vertical stretches and shrinks of quadratics. So I think you can probably do this first portion on your own. Okay, you have a summary of the rules that we know from our previous study in terms of shifting up and down, left and right, keeping in mind that the horizontal shift is a little bit unintuitive, at least it is for me, that when we add something inside the function, it actually shifts it left k units, or the absolute value of k units. And subtracting something in here shifts it right. So see what you can do with this. Pause, play with the recording when you've got some work done. All right, so let's look at a graph, of that function in our gizmo. When we subtract 4 inside the function, it shifts the function, the parabola, to the right 4 units. And then when we subtract 5 outside the function, remember, the things that go on outside the function affect the vertical. Things that are inside the function affect the horizontal shifts. So to summarize, we're going to shift right 4 units and down 5 units. That puts our vertex at the point 4, -5. Once you've jotted that down, let's think about what a graph would look like. Well, here's a graph copied from the Explore Learning gizmo. And in terms of the sketch you will make in your notes, something like this would suffice. Okay, something where we see the vertex, we see the axes, put arrows on your axes and your parabola. Okay, and then it says, where is the function increasing? Well, it's all the way from the right of that vertex, so it's increasing in the interval 4, but not including 4, all the way to infinity. Okay, now let's consider reflections, horizontal and vertical. So again, this is a review from stuff we did in our previous unit. If you negate the function, that makes all the y values negative, right? Because f of x is really like a y, right? So that makes all the y values opposite from what they were, which means they reflect over the x-axis. The opposite is true if we negate inside the function. That makes the x value negative for that particular point, and that's going to reflect, or opposite, that's going to reflect it across the y-axis. Okay, so let's see what we can do with this one. The first one says to negate the function. Basically, negate the y values. So I'd like you to work on part A and B, making the graph, making the function, making the graph, and then talk about the transformations, and play the recording when you're ready. Okay, so hopefully you paused and worked that out. You're just going to negate each one of these terms. Then you're going to make the graph. You can use your calculator to get points, or you can just use your knowledge of the transformation. It's basically taking each of those points and negating it. So if it's already at 0, it can't be negated. Negating the y value, right? Keeps the same x, y is opposite. Keeps the same x, y is opposite. If the y were positive, becomes negative. If the y were already negative, becomes positive. So that has the reflecting effect. And we just say that the transformation was that it reflected in the x-axis. Okay? And now I'd like you to think about these bottom 2 tasks, where we have to negate the x value. In other words, it's going to reflect across the y-axis. All right, so we need to first come up with a formula there. I'll work with you on this one because this one's a little bit different than ones you may have done. So if we want to negate the x value, we're going to start with the function, and instead of where we see x, we're going to write negative x. So we're going to have h of x is equal to, and then we're going to say negative x squared minus 6 times negative x. And the 5 doesn't change, right? Because the 5 doesn't have any variable in it. All right, and then we just work this out. When you square a negative, you get the positive. And when you multiply a negative by a negative, obviously you get the positive. So it's just going to be like this. So you notice that the first term didn't change. The second term did change sign. And the constant didn't change at all. And so there's our formula. And then it says to make the graph. So why don't you go ahead and make that graph, plotting the points or using your calculator, and then play the recording when you're ready. All right, so when you negate all of the x values, the effect is that for the same y value, the x is negative, it's opposite. All right, and so that reflects each point across the y-axis, and that would be our parabola there. Do want to point out that I've labeled each of these parabolas. Anytime you have more than one function on the same axis, or any time you have more than one graph on the same axis, you definitely want to label them. So I've labeled the first one f of x, g of x, h of x, etc. Thanks for watching.